Hello everyone, welcome to iTech Labs. This is a session that will be able to look at OSI Security Model. If you want to understand more about cybersecurity and also cryptography, it's always very important to analyze the OSI Security Model and also be able to explore the various types of security attacks, security service, and security mechanisms. So these are actually the cornerstone of securing any application, because if you understand where the OSI security model, you'll be able to know where the attacks really happen and on which layer, and also you'll be able to classify the various type of attacks and be able to map it to the appropriate security mechanism that you need to apply. So we look at the OSI security model is a standard that may use for security to identify the attacks, be able to identify the security services, at the same time be able to identify the security mechanisms. So these models is an international standard that provides a worldwide standard for the security of a system, to analyze the security of a system. So these models usually have three components. The first component is the security attacks. Then we go to the security mechanism. Then we deal with what we refer to as the security services. So security attacks is actually any actions that put your data overall at risk. So an attack might be successful or unsuccessful, because if there's an attack and you fear not lose any data, it means that you're able to recover the data. That means it was a successful attack, but you have implemented mitigation strategies like the DRPs to be able to ensure that you're able to recover from those attacks. So the attacks are usually classified into two. We usually have what I refer to as passive attacks and active attacks. So these passive attacks, the kind of data in which data is sent from one sender to the other, and what happens is that the attacker is able to monitor the data, do the traffic analysis, performs things like eavesdropping, and it is one of the main user attacks that is used to do what we refer to as information gathering or reconnaissance. So when someone is able to identify the data you're sending to a specific user, they're able to use that data and be able to identify which form of attack they can launch using that channel. The other alternative of the type of attack is mainly the active attacks. So these are the attacks that involve change of data and actually between the sender and receiver. So some of the examples of active attack is masquerading, where someone is pretending to be someone else. We have some others, DOS, replay, where someone is modifying data and transmitting it. So in the OSI security architecture, what we deal with, what we look at the OSI layer model, we have various layers. I think we begin with the application layer there, and we have the presentation, session, transport, network, data link, and physical link. So these are some of the most possible attacks that you'll be able to experience at given level, at different layers or levels of that. So you see from these from the physical level, you think with the sniffing, go up, you go to spoofing, man in the middle attack, and transport layer, they do be able to do a lot of reconnaissance. And this is where now you need to ensure that your data is usually encrypted before it is being transmitted at rest, or when being transmitted to various destinations. So depending on the type of attacks that you're able to experience at these layers, so it means that you have to deploy quite different mechanisms to mitigate those from attacks at those different layers. So security services on the other side, so these are the services that are used to maintain the security. These security services can be implemented using the various layers of the OSI models, and we usually have 5 security services. The first one is authentications. So this is what we refer to as assurance that the person who is connected to the system is who they claim to be. And we have 2 types of authentications. We have the peer entity authentication and data origin authentication. Confidentiality is also very key, because you want to ensure that the data is exactly, there's no, the data that is being shared between 2 nodes is only the people who are intended to see that information, who have right to access that information. So it means that you're trying to maintain privacy of the data that is being sent from node A to node B, or from node B to node A. So you have various types of confidentiality, and it's one of the main security services that we'll be looking at in the next labs. The next security service we'll refer to is integrity. This is key because we want to ensure that the data is exactly, the data sent is exactly that, like the data that is received. So you want to ensure that there's no modification, there's no insertion, and there's no deletion of data. Non-repudiation is also a key security service. This is where we want to ensure that no one can deny having participated in the communication. So if, for instance, you save someone data, you cannot deny having sent that data. If you want to receive the data, you cannot deny having received the data. So access control is overall for network security, where you want to ensure that you provide access to the resources that are there in your network infrastructure, in your applications. And with this, only implement various controls using an access control matrix to ensure that users have different rights of access to different systems and data in their systems. So these are some of the functions at different layers. You can see we are looking at the most common cyber attacks at different levels. You look at application presentation and sessions. So you have those are the main common form of attack that your system is going to experience. If you're looking at this section here, you're looking at RIP attacks. Looking at this layer, you're looking at this form of attack, spoofing, misconfigurations. If you're looking at this level of attack, you're looking at the physical threats to the infrastructure. So it's good to look at these security services and see how do you map them in the OSI model. So which techniques do you need to employ to achieve authentication? Which technique do you need to deploy to achieve confidentiality? And so to the other main security services. So to conclude in this regards to the various security mechanisms. So these mechanisms that help in setting up the security services in different layers. So we use them to provide a way of preventing or protecting and detecting attacks. Some of the main security mechanisms that are deployed are things like encryption, because one of the most popular security mechanisms, which is practice a cornerstone of security, because you want to ensure that you achieve confidentiality, you want to ensure that you achieve integrity of data, you want to achieve authentication, you want to ensure that you achieve non-repudiations, and also you want to ensure that at the end of the communication, there's a very high sense of accountability. So some of these, one of the encryption tools and using of these requires to achieve that, those security services require to use a hybrid cryptography, and this is one of the approach where you use different combination of cryptographic algorithms, things like SKC algorithm, PKC, and hash function, because they are all tailored to achieve different security services. And also, if you look at these, this node here is sending data to receive the sender and the recipient. So the idea is that they both will generate the keys, public and private keys, then the public key shared between those, and then you use a public key to encrypt, and then the person uses their own private key to decrypt the message. So basically, that implementations of hybrid crypto systems require someone to use a combination of cryptographic algorithms. So you have a look at those algorithms in our next lecture. When you look at the various models that we'll be discussing in this channel. Thank you, and those are some of the few things that we have dealt with in OSI: security models, classifications of security attacks, classification of security services, and classifications of security mechanisms. Thank you.